strengthen and promote organizations dedicated to reversing the trend of destruction of ocean environments around the world. Something we all care about a lot. Mark has devoted his career to promoting true sustainability, the economic, social, and environmental well-being of communities that enables them to thrive. And so to fulfill his role as Ocean Foundation President, Mark brings diverse legal, international, and consulting skills. He holds a BA in history with honors from Claremont McKenna College, a JD from Loyola Law School, and a master's in Pacific International Affairs from our own IRPS, now
GPS.
Changed the name, now GPS.
I'm going to learn it eventually.
Me too. So he's worked extensively in tri-national efforts in Mexico, the US, and Canada, as well as many countries in Central and South America and around the world. He's an authority on international environmental policy and law. I'm looking at what Penny gave me. I'm not sure I need to go. He's a pool of expert. He's expert advisor for many different kinds of organizations. Many of us probably know. I asked what was new and different. He's recently become a newly appointed Sargasso Sea Commissioner. You guys could ask him about that and what that means. I'm sure he'd be happy to tell you. And apparently the Ocean Foundation has also recently absorbed SeaWeb, so they're now dealing a lot more with seafood too. Clearly, this title draws an audience. Poop, Roots, and Deadfall, the story of blue carbon.
Thank you very much. It's great to be back here in La Jolla. I graduated from then IRPS, now GPS, a long time ago, and even came back there and taught for about 9.5 years, which included when CNBC was started at Scripps, and so I spent some time down here doing those little pieces of lectures on law and policy related to the ocean. And it was really a really great opportunity then, and it's a great opportunity to be back. And I love coming back to La Jolla. Anytime you need me to come back, just say so. Blue carbon is exciting to many people because it has this sort of win-win-win opportunity, right? We're restoring habitat. We are creating a buffer for storms, and we're sequestering carbon out of the atmosphere. The ocean is, oh, by the way, I have a lot of slides, and they're going to go by very quickly, but I will make them available later so you don't have to keep up with every single one of them. The ocean's like our best carbon sink, and is remarkable in the way it processes carbon and how much carbon it takes in. In talking about blue carbon, we're particularly thinking about the plants, phytoplankton in the ocean that are taking carbon out of the atmosphere. So our carbon emissions from our cars and factories and such. And just as a definitional piece here, sequestration, taking the carbon out of the atmosphere, storage is what we really care about, right? We do want to know how much we take out of the atmosphere, but it is just as important, how long do we store it? And this is where the ocean has a real advantage over those little, Amazon forests and things like that. We're dealing with how it's stored in the plant, in its root system, and then ultimately in its sediments, and how long it's stored. We have calculated a number of these places are in the thousands of years of storage. Now that's particularly critical when you think about any of the measures for carbon offsets when you plant trees or something like that, where you get your credits for taking carbon in the 100-year increments, right? And so this is a great advantage to have this kind of thing. And so when you're looking at a comparison of an average vehicle's tonnage and what a wetland area can take up and how much it can store and for how long, you can really begin to see a substantial difference. The three types of plant systems that we're most concerned about in blue carbon are seagrasses, salt marshes, and mangroves. Obviously, seagrass is plentiful. It is global. It is basically on every continent except Antarctica. And it has only a handful of predominant species, and so understanding and measuring its carbon uptake is pretty straightforward. Salt marshes, a little more difficult, a little less permanent, but also pretty straightforward to understand and think about how they take up carbon. And obviously, in this focus on blue carbon, we're only talking about this sequestration and storage of carbon. We know and understand all of the other ecosystem functions that, say, marsh grasses do in terms of filtering our junk before it gets to the ocean. Same thing with mangroves, tremendous uptake, but we also have a lot of loss of mangroves as a result of uses. And so we're always looking at these things and looking at their comparative value in terms of how much carbon they store and for how long and in what systems, how they interact with each other. But we're also looking a lot at how they interact with other habitats and systems, right? If dissolved carbon in the ocean isn't getting taken up this way, it's eventually changing the pH of the ocean. And so part of our question is, if we have a healthy seagrass meadow adjacent to a coral reef, is it helping the pH at least locally, at least during the times that it's taking up carbon? And does that really help us deal with that particular threat? So in addition to those three big categories, we know that we also have storage and uptake of carbon in a lot of other ways in the ocean. And zooplankton is particularly important in terms of how it does this. And all of this combines to be an entire sort of biological pump in the ocean to move this carbon throughout the system, take it down, bring it back up, et cetera, et cetera. And this is just photosynthesis. It's the same way that carbon is taken up by our forests. So this isn't, we're not suggesting this is something new and different that the ocean does differently than any of the other systems that are already certified for carbon offsets and carbon uptake and international agreements. One of the newest pieces of conversation around blue carbon is vertebrates and their role that they play in the system. And a new publication, which is entitled Fish Carbon, highlights that there are 8 different mechanisms that we're looking at to understand this part of the pump biological cycle and how it moves carbon. Now, I've got a slide on each one of these, but I'm not going to spend a lot of time on how grazing animals deal with carbon, how carbon is involved in the biomix in the system, and how it then gets excreted by the animals who eat it, how it is part of what whales do and how their poop is available as nutrients for other parts of the system. This becomes part of how all of this happens. And so you have the carbon collected, moved, eaten, excreted, et cetera, as part of this whole process. And part of this comes from a sort of conservation argument of, we want to try and save the whales again, partly perhaps because of their role in this carbon cycle, right? Thinking about how much carbon they take up every day and where that carbon ends up. The Twilight Zone feeders who come up and eat the phytoplankton and zooplankton at the surface and then go back down during the daytime, again, is another way this carbon is pulled and taken down to where it might be stored. Flesh storage, tissue storage of carbon itself, and then of course that falls upon death of animals and ends up in the sea floor. And these ways become part of how we are thinking about carbon for vertebrates and their relationship to the entire system, right? And I like this because we're thinking holistically about an incredibly complex system rather than saying, oh, we only want to plant seagrass, or we only want to restore mangroves. That sounds simple, but this allows us to acknowledge how much more complex it is and allow us to recognize the zooplankton photosynthesis in a way that it's being missed by those three systems that are currently up for certification right now. So blue carbon needs exactly the same things that all of us want for the ocean all the time anyway, right? We want it to be healthy, we want it to have good, clear water quality, we want natural levels of nutrients, not excess introduction of nutrients. We don't want these plants killed by pollutants from land-based sources, and we don't want everybody driving their boat through the seagrass meadows and putting prop scars through, grounding their boats, powering their boats off of the meadows, all of that sort of stuff. So those are the primary threats to blue carbon: climate change, onshore activities, and overfishing. Climate is fairly obvious, right? I mean, we're making actual physical changes. If you think about the basic idea that seagrass has to do photosynthesis underwater and sea level rise happens, can it move fast enough, migrate fast enough, grow fast enough to keep up, right? It has a tremendous range from fairly shallow to much deeper water, but do we understand exactly what's going to happen with sea level rise? What is sea level rise going to do to coastal marsh grass areas? What is it going to do to mangroves? And have we left a buffer for migration of these plant systems towards shore? Human activity I already mentioned. I mean, we take out mangroves to build shrimp farms. We take out mangroves for cow pasture. We take away seagrass meadows in front of resorts because tourists don't like walking through them. I already mentioned wreck fishermen and the like powering off of meadows once they get high topped, and all of this adds up to a tremendous loss. The biggest expanse of seagrass in this country is these huge flatlands around Florida. We lost a lot of that seagrass because of poor water quality. The Clean Water Act and the Clean Drinking Water Act have substantially improved the water quality all around Florida, and so our opportunity to bring the seagrass back there is fairly good because we've taken away one of the biggest threats, and so getting rid of these threats makes these systems more resilient, makes them available to take up more carbon, and that makes a difference. This is what I was just mentioning, all these forms of pollution that go into the water and how they affect marsh grasses, mangroves, and seagrass, and for that matter, plankton and everything else. To the degree that this vertebrate carbon and the whole biological system and pump is critical to this cycle of carbon in the ocean, we have to be concerned about taking too many fish out of the sea, too many marine mammals out of the sea, too much krill out of the sea, et cetera, because we're taking away this functionality, right? And so worrying about this problem in relationship to carbon is an additional leverage we have to talk about why we should fish at a level that is sustainable rather than fish at a level that exceeds carrying capacity. So if those are the threats, what are the solutions? The good news is this idea of blue carbon at all is a conversation. It is gaining ground. I think that we are, when we first began talking about this about, a decade and a half ago, everybody, scratched their head more than anything. They didn't, think of this in the same fashion. And we even had opposition when we talked about it in the context of climate negotiations from folks who worked on forestry and forest conservation, because they were like, no, we want to have carbon offset credit payments for restoration of habitat come to forest conservation, please don't compete with us. Which tells you a little bit about even our own conservation community's focus in the world. The good news is that at the Paris meeting, COP21 last December, oceans were front and center in a lot of the conversations. And blue carbon was as well as part of the solution, part of the understanding of how the carbon system in the ocean works and how the uptake works. UNEP and GEF have a huge blue forest project that is, well, we participated in the application for this, and the application for the funding was 563 pages long. That alone was a waste of carbon. But it's a multi-billion-dollar, multi-year project to pilot a lot of this restoration and do measurements globally and understand what's going on in this system. We've seen a lot of good pilot projects. This one in Kenya is really interesting. One in Abu Dhabi, which was a great project because it failed, right? Huge investment by the country, huge amount of mangroves planted, huge amount of effort put into it, and the measurements of carbon uptake and storage didn't play out exactly the way everyone predicted they would do. And it's turned out that it's a smut in this particular system, and the lower nutrient quality in this area taking longer for the plants to grow, and therefore it's taking longer for them to take things up. And that's the part of adjustment we all have to make, right? If we plant seagrass in Florida, it grows really quickly. If we plant seagrass up in Narragansett Bay in Rhode Island, it's not so quick, and it doesn't take carbon up as quickly. But it still takes it up, and it still stores it for a long time. We're also seeing federal policy related to this. John Holdren was here last night and spoke at UCSD about all of the different science and technology policy of the White House. And one of those was the National Ocean Policy Implementation, which includes a focus and request that federal agencies pay attention to the opportunity of blue carbon. Specifically, NOAA, FEMA, Army Corps, et cetera, all are supposed to be paying attention to this opportunity going forward. And they're working with Restore America's Estuaries and other organizations, which I'll come back to Restore America's Estuaries in a minute, because we've been working with them on certification on this stuff. Some of this is pure regulatory. Some of it is anticipating the idea that you would have tradable offset credits and a market for those credits to encourage action and activity related to restoration, right? This is, we could very simply say we want to take carbon out of the atmosphere and we want to store it safely and store it for a long time and be done with this conversation, but we also need to know how to fund that, right? We need to do this at such large scale if it's going to really make a difference in the carbon in the atmosphere and climate change. We've got to have a huge amount of cash coming in. Part of what we're seeing is the EU is requiring certain industries, particularly public utilities, to offset their carbon emissions. The state of California has something similar. Florida has a very teeny tiny program. Those regulatory requirements mean that those folks have to pay for their offsets, and they have to have some certificate of proof that the offset took place, which means that there's somebody taking care of getting the restoration done, monitoring it, and measuring what's going on. And that's part of the challenge of making this even more important. So Restore America's Estuaries has done a number of projects around the country, thinking through how you do this, measuring how it's done, and I think it's been a remarkable project, and they've been a great partner with us, both in terms of saying, okay, how much carbon are we dealing with here, but also how much value is generated by this, right? Because as this other side benefit, you're improving fisheries and you're diminishing the harm from storm surges, there is economic value to that, right? You're not having to pay to rebuild a building. You're not having to pay to put a pier back in that's been destroyed. And you have tourism and rec fishing industry revenues coming into your locale or your state by having that habitat there for the fish. And then I already mentioned that this is a mechanism for funding restoration efforts. Congress, despite all of the polarization in my new hometown, has paid attention to this issue and has integrated it into a couple of the American Power Act and Clean Energy Partnership Act. We just don't tell them that they're addressing climate change, okay? We have been doing seagrass restoration under this name since 2008. We've done restoration projects in Florida and Texas for seagrass, for marsh grasses in Narragansett Bay and Mobile Bay, all with the idea of just, give us a donation and we'll do the restoration. As we did that, we became more and more interested in understanding how much carbon was taken up and how much was stored, and so we began looking to, at least in our case, synthesize the science that was out there, understand who was working on these issues, correspond with them and understand where they were going, what they were learning, etc. And this led to us working with Restore America's Estuaries to apply for certification of the blue carbon offsets from seagrass, mangroves, and marsh grasses. It's 4 species of mangroves, 2 species of marsh grass, and a couple of species of seagrasses. Obviously, we talk about all these things that I've already mentioned, right? The safety benefits, the food and habitat and economic benefits. But the methodology we're talking about is when you actually do a restoration project, can you measure how much carbon is sequestered from the atmosphere, how much is stored, and for how long it is stored? That was certified in late November last year. So we now have the ability to do these restoration projects, calculate their carbon uptake, and have it be a certificate that can go into those kind of tradable markets, right? So in addition to what we have been doing of take a donation, do the restoration, we can now do the restoration, get the credits, and then sell them to those regulatory systems where folks are required to offset. Now, that's just what's called a restoration credit or a direct benefits credit. It's we are actively planting, restoring, doing something, right? You've probably heard in the forest example what is called a conservation credit, which is the forest is already there, it's already working. What is the value of the locality, the country, et cetera, not destroying it, not cutting it down, not re-releasing that carbon? Are we willing to pay for that as part of our carbon management system globally? And we will do that next. So the Ocean Foundation and Restore America's Estuaries will work up the proposal for how to value these blue carbon systems under a conservation credit next. To get this first credit took 3 years and about $250,000. I expect that the other credit will take just as much time and just as much money, which is a substantial investment for us as a nonprofit, but we've made it completely open source. Anybody can get this methodology and use it to do restoration projects and earn credits. We aren't making it proprietary. We did, however, create a mechanism so that we can raise money to do these restorations with this methodology in mind. You can go on to the Seagrass Grow website and calculate your carbon footprint and pull out your credit card, and we will then plant that much seagrass or marsh grass or mangroves to offset your trip, household, or small business's footprint. And it's a nice system and has been it's really truly being launched today. We've got the website done a week or two ago and have been soft launch testing it, and we will be fully launching it and telling people about it this month. If you look at the price of carbon offsets, you will find it as low as $4. You will find it as high as $22, $25 a ton. Our cost to do it in seagrass is right in the middle. So I think we have a potential to be relatively competitive in thinking about this way to bring revenue for seagrass habitat restoration. I already mentioned this is a relatively new concept. It's not, something that's on the forefront of everybody's mind, but I think it's something that we can demonstrate over time. We can use this methodology and action to create a track record and make this all go forward. Coming back to where I started, if we do this, no harm done, right? Hopefully we'll take up some carbon, we will hopefully store it, but we will also create habitat and we will protect our coastal communities from storm surge. And I think that fundamentally gets a lot of people engaged, even if they don't believe or choose to deny climate change. That was one of the great lines last night from John Holgren. He went last summer to the Small Island Development States Summit, which was in Guam, I believe. And he said, in the small island developing states that are threatened with inundation in the next 20 years, there are no climate deniers. Funny that. So let me stop there. That was about 30 minutes, really fast throw at you blue carbon. And I'm happy to answer questions about blue carbon or the Ocean Foundation or even the Sargasso Sea Commission. So, what would you like to know?
Just to get some perspective, if you took a jet airline flight from here to the East Coast, how much seagrass would you have to plant? Just to get some sense of scale.
Yeah, it would be about 2.5 tons, so $25. Okay.
So, please correct me if I'm wrong, because I don't feel like an expert in this area at all. Just trying to characterize this thought I'm having the whole time that you're speaking. So we know that as we're storing carbon in our ocean at obviously a rate that is too great, so we get ocean acidification, right, as a result. But it still does store a lot, and that's good stuff.
Yeah.
Have they found, or are there similar sort of things that can happen with seagrass beds or mangrove fields in which they can have a weird byproduct by storing too much too quickly? Or is that just something that it doesn't really exist, or is that something that we kind of know or sort of planning for, or am I just making up a story?
So the deposition of carbon from the atmosphere in the ocean is exceeding the ability of the ocean to take it up, which is why we're getting to the ocean acidification problem. Part of that is we lost so much of the ocean's capacity to take up carbon. So part of the idea here is we restore as much of that capacity as we can, as fast as we can. I think the assumption is that those plants won't take carbon up any faster than they normally do, but there will be more plants and more opportunity to take up carbon than there is now. I mean, I don't remember the exact numbers, so don't quote me on this, but if we lost 60% of the seagrass surrounding the state of Florida and we put all of that back in, that creates a capacity to take up carbon out of the ocean, right? And so that is a good thing. I don't believe I've seen anybody worry about the exact problem you're talking about, which was the plants taking up more than they could handle. So,
Okay.
yeah.
That was a really interesting talk, and I had no idea that seagrass we're sequestering so much carbon. But my impression is that seagrasses in many parts of the world have been retreating, and it's partly due to things like, too much nutrient input, and so that, there's, they're sort of in competition with, things overgrowing and so on. So I guess my concern is if you're trying to restore seagrasses, and it's an area where, they just won't take in the long term because of too much nutrient input, is that a problem?
Absolutely a problem, and that's why I mentioned Florida again. They've done so much work under duress from the federal government under the Clean Water Act and the Clean Drinking Water Act that the water quality has improved enough that we can do restoration there. I turn around and I'm working with some colleagues at the Discovery Bay Lab in Jamaica, and they're having a hard time. They have to find particular places around the island where they can do seagrass restoration that aren't getting too much nutrient from frankly, sewage runoff.
Yeah. I have two questions actually, but the first is sort of related to Tony's. So is there a component of the blue carbon initiatives around that are working towards sort of the end that reduces destruction of these habitats, like getting people to avoid farmed fish, shrimp that came from destroying mangrove habitat, or the cows that you were talking about, or whatever? Is there an arm of that effort
Yep.
that's focused on that?
Yeah, absolutely. So we're actually, for every dollar that comes to the Ocean Foundation for blue carbon restoration, a small piece is for administration, obviously, but we are holding back 10% of every dollar for an education program. We are piloting that education program with the support of the Turner Foundation right now in the Florida Keys National Marine Sanctuary, focusing on convincing, in that case, the limited category of recreational boaters and guides, please don't run your prop through the root structure of seagrass. Please don't ground your boat, et cetera, et cetera. I think there is, at the same time, a whole lot of efforts, not linked as well as they could be and should be to blue carbon, on the, let's stop destroying mangroves for shrimp farms. There's so many good reasons to stop making shrimp farms in former mangrove habitat anyway, that we don't necessarily need to add this additional leverage, but I'm happy to do so. Is that your second? Yeah?
Yeah.
And then we'll go some more.
So my second question has to do with warming of the ocean and whether we're expanding mangrove potential, mangrove habitat. Has anybody done the calculation of, could we get new mangroves in places we don't have them? Are they more efficient than what we might lose? I guess that salt marshes maybe, or,
Yeah. That's actually a great question, and one that I've asked a number of times, and the answer is I don't believe so. I don't think we have that calculation, but that is exactly the kind of thing. If we have these, if the systems all just move with the sea level rise back towards human habitat, and it's blocked, we have we can't. It's not going to make a good bit of difference. If there is a ability for it to do that and for it to expand, and frankly, carbon helps the photosynthesis, so the plants grow faster, and thus, so we have potential for this to increase over time if we have the space for it to migrate and grow. Yeah.
So I was wondering, with the economics of blue carbon, could there be a new mechanism for supporting marine reserves? And that marine reserves protect a lot of blue carbon, and there could be, carbon offset funding that helps the marine reserves to...
Yeah, exactly. And that's, so if you think about the terrestrial example of forestry, a lot of the Amazonia is protected, not well enforced, but it's theoretically protected, and some of it is funding that comes from these different mechanisms to say, okay, this is a protected area, we're going to keep it a protected area, and one of the ways we're going to finance it is through this carbon conservation credit. We have to get that carbon conservation credit in order to support something that already exists, but I think that's exactly the idea, is to have that kind of funding mechanism.
Ocean acidification has been mentioned a couple of times. Is part of the reason that you don't sort of touch into that or go into that is because this is really presenting a very optimistic and positive way of approaching some of these problems, or is it just because that issue in and of itself is rather complicated to try to describe to maybe the audiences that are the ones that are the focus of this effort?
So going back to my initial thing of invite me back anytime you want, I have another one of these 60 slide things on ocean acidification I can do. Thank you. Part of the answer though is there are 2 or 3 researchers that we're following who are asking the question of if these plants are taking dissolved carbon out of the ocean into their plant structure and system and storing it, et cetera, is that making a difference on pH, right? And the initial sort of snapshot is yes, it does. But I don't think there's enough science on that question yet to link blue carbon to being a really hard solution to ocean acidification. Yes?
How do you determine where to plant the seagrass bed offsets?
So we started in Florida because the donor wanted to start in Florida. We particularly picked the Florida Keys National Marine Sanctuary because we had the full and complete cooperation of the manager of the sanctuary. Because of that, we learned everything we needed to know about the feds and the state of Florida's rules and certifications and permissions and et cetera, so it became easy for us to do restorations there. But we have now expanded to doing a few in Texas, and we have one new donor, Columbia Sportswear, if you use any of their clothes, is one of our donors for this project. And they would like us to take this internationally. They would like it to demonstrate that it can be done in a number of places around the world where they sell product. And that's a partnership that drives a decision. I like to pick places, going back to the other question earlier, where we have seen and demonstrated improvement in water quality and therefore the success potential of recolonization is high. We have also been using one particular technique a lot, which has been to go to places where everything around is healthy, but somebody drove a boat through and bring that place back up to grade and prevent it from further eroding and at least get some start with seeds and plant plugs if you can, or even just let it be, and having it back at grade with appropriate soils will allow the recolonization. And so I'm picking places therefore where I know that there's already a healthy meadow here, and presumably in this place there was already healthy seagrass, and I can get it to grow again. Yeah, Martha.
Hi. When you have a project, seagrass project that involves increasing the tidal flushing in estuary, like we have a lot of problems here in Southern California, so is that when you bring in the Army Corps of Engineers and city planners and all? Because I can imagine growing seagrass, it doesn't work until you get the tidal flushing.
The simple answer is yes. The more nuanced answer is I haven't had to do that yet. And the Army Corps is not my favorite institution, so I'm putting it off as long as I can. Yeah.
Is carbon neutrality a reality? Is that a realistic goal that you see possible for like the state of Florida?
That's an excellent question, and it's a very tough question. I think that, if you or I calculated our own carbon footprint and we went out of our way to offset it with something like this, or forests, or paying native energy to build wind machines, we're at least recognizing the cost that we're the harm we're doing has a cost, I don't think it's perfect carbon neutrality, and carbon neutrality is probably something that's achievable at certain different scales, right? Can I offset exactly the right amount of carbon or excess amount of carbon from a airplane trip? Yeah, probably. Can I offset, get to carbon neutrality for an entire city? Maybe not. It's hard to capture everything. But good question. Yeah.
Mark, I apologize if you already answered this, but why is seagrass 50 times better than certain terrestrial plants at sequestering carbon?
So it sequesters carbon out of the atmosphere more slowly. Well, let me start back 2 steps. So when we started talking about this, we started talking about planting trees and having trees take up carbon. We then began to talk about field grasses, which took up carbon faster than trees and moved it to the sediments in the soil faster than trees do, which is a how long is it stored question, right? So we then get over here to seagrass, and like field grasses, it moves things into the soil sediments faster than a lot of other plants do, which at least reduce the chance of its disturbance and the long-term storage. And so the idea is that forests can catch on fire, field grasses can catch on fire, field grasses can be plowed, altered in some fashion. Are seagrasses less likely to be disturbed and less likely for that carbon to be re-put into the water column? And the general analysis is yes, right? We did this all in Florida, and then the law changes in Florida and says, oh yeah, you can rip up seagrass anytime you want, that advantage will be lost. And so part of this requires a steady state of the rule of law in places that it may exist and may not exist, but it's the better than others has to do with how long is it stored.
I just gave my lecture in class today on invasive species, so this has me thinking, and we were talking about the fact that the way people view invasive species is changing, and there are invasive seagrasses, right? So my question is, can you see people planting seagrasses that are not native to an area for the ecosystem services that they might provide in the way of carbon storage?
That is a really great question, and I haven't come across that yet, but that would certainly be something you want to balance in things.
Was all over Washington.
Yep,
State,
yep.
and they-
Yeah, I was wondering whether, have they stopped taking it out?
Yeah.
Maybe this time of day.
Yeah, that's
Yeah, I
great.
mean, can this change the way we view a lot of invasive plants
Yeah.
in the ocean?
Yeah. It might.
So you point out the importance of the difference between sequestration and storage of some-based systems that lots of carbon for thousands of years, and it can take a really long time. So it seems like, as other people have mentioned, protecting existing wetlands could be way more bang for your buck than restoring. Do you have a sense for why there's been more enthusiasm about restoration in some parts of the blue carbon community than there has been about conservation?
So we talked to a lot of the third-party certifiers, and most of them weren't willing to try an entirely new certification. They were busy with forests, they were busy with other things, and VCS was the one who was willing to do it. And they wanted to do the simple version. How much, if I have a square meter of seagrass brand new, how much carbon is it going to take up, how much is it going to store, and how long is it going to store it? They wanted to start with that as the baseline for thinking about the conservation credit, which is why we have to do it second. I completely agree with you, and I would have gone there first for the same reason, but no one was going to let us do that.
I feel like somewhere in the last 10 years, there was this sort of personal carbon offset idea that was bigger, right? I feel like I remember booking a plane ticket and there being a little box I could check, and I could pay $5 to offset,
Yep,
right?
yep.
And then it disappeared. And I feel like you're resurrecting this a little bit with the seagrass. Do you have ideas about why it disappeared, how effective it was, what happened with that?
Like many things in environmental conservation, you bring something like this up and people are like, oh no, don't do that. It's just going to encourage people to keep driving their big cars and taking long plane trips, et cetera, because they can just pay indulgences for doing so. And so there was a lot of criticism of this, and I probably should have said this already, but you know, this should be our last resort, right? We should figure out how to reduce our carbon footprint and get rid of automobile use, plane flights, et cetera, anything we can to make our impact on the planet less. And then the things that are left, we should figure out how to offset, right? This should be our last resort, not our first play. We do know that United Airlines, JetBlue offer offsets to their customers when they buy tickets. We have been slowly breaking down the walls and getting conferences, particularly conferences related to the ocean, to use our offset program. So the World Ocean Summit that The Economist did uses our offset program. The International Sea Turtle Society has used our offset program for a number of years. We're trying to put that back in. I think it appeared and then disappeared because of this sort of criticism that we were encouraging people the wrong way. So, yeah.
No, I actually beg to differ with you.
Okay, good.
So, of course, by the mitigation hierarchy, the residual is what you offset. But if you look at it from a least cost conservation perspective, so you have a budget constraint, right? So the question becomes, how do you best allocate your funds among all the four components of the mitigation hierarchy in order to get the maximum bang for your buck, right? So in that case, so if you take the previous steps in the mitigation hierarchy, you're going to start reaching diminishing returns, right?
Yeah.
You might even get into negative returns. It's possible. So if you look at from trying to doing the best you can to sort of equalize your marginal costs across the marginal impacts, then I would say actually that it would not be a residual activity. It would be an active process by which you get least cost conservation spread out across all four steps. So it's no longer strictly residual. It's part of a least cost conservation package, and you'll get more conservation in the long run. All right, and also you'll establish stronger incentives as well for conservation. So I actually think it's a much more effective approach than a residual.
Good point. Very good point. Yeah.
What is the risk in the sense of climate change and bigger storms, hurricanes, of doing these projects with just having them quickly wiped out?
Yeah. So obviously, if you do a fresh mangrove planting and it's not rooted, its ability to withstand a huge storm is very, very small. And so you have to worry about timing and seasonality and all that sort of stuff. These plant systems that are underwater seem to survive storms relatively well. Even a couple of places where we've had sprigs, usually secured in some sort of like biodegradable cotton, so that you'll fill the divot in an existing meadow with local soils and comparable soils encased in a biodegradable cotton, and then put the plug in. Those things haven't moved and they haven't lost the plants. So I think, yeah, we could have such a violent storm that it could tear all sorts of things up, or more likely have the entire contents of houses at the beach wash out and bang around out there and take out stuff that we'd have to repair again. And in doing so, releasing carbon in the process. Another reason to retreat from the beach. Yeah.
Do you have any process in place to maintain the genetic diversity of the seagrass? Like, are they coming from multiple sources and things like that?
Again, a great question. So that's one of the reasons why I like figuring out these places where we can go and restore it to grade with similar soils and allow it to recolonize on its own, because we're not taking a bred plant and putting it in. That should be our last, I'm going to stop saying last resort. I would prefer not to get into, sort of the idea of what do you call it when you do lawns that are all identical and That we don't, if we can avoid that, we should.
Yeah, how hard it is to reintroduce seagrass to a previously disturbed ecosystem, even though the water has been cleaned? I mean, there's probably some difficulty with sediment, like heavy metals and things like this. How easily the new seagrass attaches and dumps?
Again, we've tried to do it in places where there's already a healthy meadow, and put in soils that are local soils so that they're similar to what's already there, in the hope that it will recolonize on its own. We have had some places where, for example, these are not projects that I've done, but the Army Corps and other folks have permitted a pier to be built, and folks have gone in and taken out a piece of seagrass and moved meters of seagrass to some other location where there used to be seagrass. And it's got a better than 70% survival rate, but it's not perfect. We've also looked at some of the folks who have just done seed scattering in places where there used to be. Less than 50%, sometimes less than 30% success rate, but it's really inexpensive. So, yeah.
I'm thinking of a couple of public perception issues. So the first, I'm wondering if, especially in the promotion of marshes, if you've encountered any questions about the Zika virus and how that, like how you might have mitigate or I guess managed any response in regards to that. And then also the second one is, you mentioned that a lot of the removal of seagrasses is, in front of hotels and things where people feel like it just doesn't look nice or don't want to walk on it. Have you had to do any kind of rebranding for the public's perception to improve on these areas?
So the first question on marshes and Zika hasn't come up at all. Now that's probably because Zika is so new a conversation. We started our marsh grass restoration in Mobile Bay 7 years ago, and it's a 5,000 acre restoration project, and we're a third of the way through it, and everybody locally is absolutely and completely overjoyed. Right. Yeah, it's also saltwater, which is a good point. Maybe it's filling in places where ponds were evaporating all the salt and could have mosquitoes, and so I'm going to hire you to help take care of this conversation. We're getting rid of Zika mosquitoes by putting marsh grasses in. The second question is part of what we're doing with this 10% holdback I was talking about. We're trying to re-educate people, fishers, tourists, communities, community planners, et cetera, that this is really, really valuable for storm buffering, for habitat, and oh, by the way, it also takes up carbon, right? And, I think we have some potential of succeeding when it comes to the fishers, because they see a much more direct connection between their livelihood if they're a guide or their pleasure if they're a wreck fisherman, fisher person, and I am focused on that right now. I also think we are having great traction with city planners that instead of riprap or armoring of other kinds, that these natural systems are much more effective and much more cost effective, frankly. Hoteliers and tourism, we haven't quite broken into that conversation yet, but I think it's got to happen at some point. All right, one more.
Do you see some specific challenges bringing this to an international scale, like barriers to entry with more deregulated countries, being able to report?
Yeah, I think that there'll be some countries where the rule of law isn't sufficient for me to feel like I can go in and feel these places are going to continue to be protected. I think there are other places where water quality standards aren't high enough to make it worthwhile to do this. But I think that if we pick some places in the Caribbean, to demonstrate the value of doing this. I think we can begin to, again, make the cases that there's a good reason to do this and it makes a positive difference, that then will encourage others to see the value.
Okay, I think we're gonna end it there. Let's
Great.
thank